The lesson topic for this video is writing equations for systems. So we've already learned how to write equations, linear equations that is, in word problem situations. And now what we're going to find is that we are going to have a little bit more information here than on the previous examples. And there's enough information here to write two different systems, or equations, which then is a system of equations. So this first example says, a large pizza at Palanzio's Pizzeria costs $6.80 plus 90 cents for each topping. The cost of a large cheese pizza at Guido's Pizza is $7.30 plus 65 cents for each topping. How many toppings need to be added to a large cheese pizza from Palanzino's Pizzeria and Guido's Pizza in order for the pizzas to cost the same? And we're not going to worry about tax here. All right, so what you probably noticed that we have two different situations. All right, I'm going to underline in red here. The first situation is how much pizzas cost at Palanzio's. The second situation is the cost of pizza at Guido's. Now let's just take one of those at a time. Let's start with Palanzio's. Think about when we wrote equations for lines earlier this trimester. What type of linear function are we going to use for this information? Again, the large pizza costs $6.80, and then we add 90 cents for each topping. Keep in mind that our three types of equations are slope-intercept form. Remember that slope-intercept means that we've got some kind of original amount plus something being added or subtracted over and over. Or we've got point-slope form, and point-slope form is often used when we have a certain amount that we know at a point, which is typically not the starting point, so that'd be our x1 and y1, and we also know a rate of change, or we have two data points. And our third type that we have is ax plus by equals c, which is standard form, and that is when we have two different amounts being added, which gives us some sort of total. So which is this situation here? Hopefully you notice that it is when we have a starting amount and something being added over and over. So our first equation is going to be that the total cost of the pizza is going to be, well, let's think about it. Our B value is our starting amount. That's the $6.80. So I'm going to put this over here. And then what value is being added over and over and over, which would be our slope? Well, that would be the 90 cents. So we're going to say 90 cents times the number of toppings you put on plus the $6.80 that we had to start with to order the pizza. Now the other company has the same situation really. It has a starting amount for the pizza. So I'm going to put that over here, $7.30. So their pizza costs more to begin with, but their toppings are cheaper. So $0.65 per topping. Multiply that by the number of toppings that you want on your pizza, and we add that to our original amount. So here's our system of equations that we would need to use for this problem. At this point, we are going to just keep practicing writing our systems of equations, and we're not going to practice solving them. And in fact, we're not going to solve this by hand. We're going to talk about solving this, using our graphing calculator at a later time. Let's try another example. So this second example says, the Frosty ice cream shop sells sundaes for $2 and banana splits for $3. On a hot summer day, the shop sold 8 more sundaes than banana splits and made $156. So I didn't include a question here just so I wouldn't confuse you quite as much, maybe like the previous example asked us to actually find the answer to something. But this I just want us to work on practicing writing the equations for this situation. All right, so again, a couple different things going on here. We know that sundaes are $2, and we know that banana splits are $3. And that's money, obviously, right? And we also see money over here. They made $156. So what we have here is we know that the number of sundaes they sell for $2 plus the number of banana splits they sell for $3 is going to add up to, the total amount of money there is going to add up to 156. So you might recognize this as being of the type ax plus by equals c. All right, two amounts being added together to get a total. So we have our sundaes. Let's say $2 per sundae. One thing that I should have mentioned in the previous example as well, defining our variables. Defining our variables is going to be helpful in this, like I showed on previous lessons. X in this situation I'm going to use as number of sundaes sold, and Y is going to be the number of banana splits. Now, remember, that's not how much each of those are because we already know that answer. We know how much they cost. So it's how many they sold. So back to our equation, we have $2 per sundae that we made. So $2 times X, the number of sundaes sold, plus we have $3 per banana split sold, and Y is the number of banana splits. And that is going to equal our total number of dollars taken in, which was $156. So now where does our second equation come in? Well, what you might notice, looking for additional numbers that are in our problem, it says the shop sold 8 more sundaes than banana splits. That is going to help us write another equation. So if we think about it, it's saying 8 more sundaes than banana splits. So how many sundaes? Well, the number of sundaes here is going to be however many banana splits they sold plus 8 more, right? Because there's 8 more sundaes than banana splits. So how many sundaes we sold, or the person sold, is, number of sundaes is X. So I'm going to write X, the number of sundaes sold, was however many banana splits they sold, plus 8. Now this is one of the ones that some people really have a hard time seeing how that works, but if you read through it again, it'll make sense, I think, to your brain. So X, the number of sundaes we sold, is equal to the number of banana splits we sold plus 8. Because the shop sold 8 more sundaes, so the number of sundaes needs to be larger, right? 8 more sundaes than banana splits. So this is the system of equations that we would have for this problem. All right, one last example. This says, at a restaurant, the cost for a breakfast taco and a small glass of milk is $2.10. The cost for 2 tacos and 3 small glasses of milk is $5.15. Which pair of equations can be used to determine T, the cost of a taco, and M, the cost of a small glass of milk? So again, we're looking for the equations that we can use to solve this. Hopefully you noticed right away that we've got 2 totals, $2.10 for this total, and we've got a total for $5.15 for this one. So it's 2 different situations. Let's say one person goes in and orders one taco and a small glass of milk and gets charged this much. Another person walks in and wants 2 tacos and I guess they're very thirsty, 3 glasses of milk, and they're charged this much. So what you should notice is, hopefully you notice, is that these are 2 examples of standard form. All right, so the first one, let's first define our variables. All right, and it actually is so helpful. You're going to look right here, and it's actually going to tell us what we're trying to find. And it says T and M in here. I'm going to use X and Y because that's not a big deal. So which pair of equations can be used to determine T, the cost of a taco? So I'm going to say Y is the cost of a taco. Okay, and Y is then the cost of a small glass of milk. I'll just write milk. All right, so for the first equation, we have a breakfast taco, so that's X for the cost of 1 breakfast taco, plus 1 small glass of milk, so that is the cost of a small glass of milk, and I know together they add up to $2.10. The cost of 1 taco, 1 milk is that. The second one, well, we have 2 tacos, so 2 times the cost of a taco, plus we have 3 small glasses of milk, so 3 times the cost of the milk, and that will equal $5.15. So, more practice on this in class. We're just continuing to write equations using the 3 different types of linear equations that we've learned.